So here's the Hobo Datalogger Pro 2. It's a temperature datalogger recording device. There's two thermometer probes with stainless steel metal covers that connect to the datalogger. It gets configured and deployed with this USB optical base station. It gets hooked up into the base station via this black coupler, and you'll hear it connect. It's connected, and at this point you open up Hobo Pro, which we'll do in a second, and define the parameters in which the datalogger will run, time interval, Celsius versus Fahrenheit, etc. The base station with this onset company comes with many different couplers. This one is used for water level, and it has a little different end to it, and it goes on here. And then if you had a water level datalogger, not like this Hobo thermometer here, you would then connect your water level datalogger to that. So there's a lot of extensibility with these devices. Today we're going to look at the thermometer piece and launch it and see what story the data has to tell. So welcome to my busy desktop. There's a lot of stuff over here. I apologize. We're going to go and get Onset Hoboware, which is right here, Onset Applications Hoboware, and it comes standard with the datalogger. It's also educational sharing, so if you need it, I'm happy to share that with you. There's demo versions and stuff online at Onset too. So Hobo's launching, and here's the interface that works with the USB base station as well as the datalogger with the many devices that can couple with it. A couple of things here. There's some icon-based launching and readout features. There's also a place to change from US to SI, Scientific International units, depending on what you want to do. US is kind of a nice take-home message for the kids who are a little bit younger. SI gets in a little more older kids. It also is good exercise in conversions if you wanted to do that. So we're going to stick with US as our units, and we're going to go to Device. And typically when we go to start using the datalogger, we're going to go to Launch. In this scenario, it's going to say that there's stuff on here. It's going to be erased. Don't worry about it. Just say yes. Hopefully the last time you used it, it got downloaded. And at this point, we're going to have a splash screen for our description, and we're going to do a test run. And I'm going to usually define it by either something in space and time. So today we're going to look at two different temperatures, ambient temperatures of the air on a southern aspect, and then maybe 10 centimeter soil. So I'll do air and soil, and then I like to put the date in which it was launched. So it's 6/16/2012. That kind of gives it a nice reference for archival purposes, and it also hammers home the message of housekeeping and systematic approaches to scientific method. And configuring the sensors, there's two temperature sensors that I showed you in the beginning. There's temperature 1 and temperature 2. You can add an interval, and you can set your logging interval. There's also filters to set. At this point, we're going to set one filter to show the maximum every hour, and we're going to do create new series, and then we're going to show the temperature, the minimum every hour, and we're going to go done. And we're just going to do that for temperature 1 so we can kind of tell the two apart. Logging interval depends on really what you're measuring and how fast it's changing. Ambient air and soil, I think logging every 30 minutes to an hour would be good. We could do an hour. It's 7:43 right now, as you see down here, so we'll let this run most of the day, and then we'll come back to it and see what happens. It's really good to get yourself and your students, as well as other professionals you're thinking and working with, to really think about how they want to plan the experimental design. So the data and the launch and the analysis can really tell a story and minimize field effort and maximize output and display, and hopefully reporting results that are going to be really valid. So you can start your logging either now, which is right now, or if you need to run out to the field or someplace that's far away, you can set a date and time. So right now I'm about I'd say I'm about 15 to 10 minutes out from when I'm going to launch. So I'm going to launch it at 6:16, 8 a.m. Nice round number, delayed start. I can go put it in and get it all set up. And then once 8 rolls around in about 16 minutes, it'll go. Delayed start. The logger sees a side limit support of waterproof shuttle. This firmware earlier using waterproof shuttle is recommended. Let's just say don't intend to relaunch the waterproof shuttle. Yes. So it's set up for a delayed start. And we're all good. So in about 6 to 8 hours, we'll come back and do what we call readout and look at the graph, as well as look at some of the exporting options into Excel and other spreadsheets, and really start to analyze real data that we've collected in a mathematical sense and statistical sense to tell a story, as well as fortify results and summarizations of the environmental system you are looking at. Thanks very much, guys. Take care. So here's our field site study area. It's always fun to keep in contact, especially with kids, like a play area or something that might have some kind of fun relationship. And we've got our tools up here. I've got a 3-foot piece of rebar measured out in a 10 centimeter increment, just about 3 inches, with some yellow tape. Here's the Datalogger device, and it's always good to have a few little cable ties. So for the install, this piece of rebar will stand up in the ground like this, and we will cable tie the probes to it, as well as the sensor, kind of make a nice little sampling site area, all kind of self-contained. There's a plus and minus to this. It's nice to have order in the field, so it's easy to maintain if something does happen, but it also paints a kind of glaring picture as to what this is, and curiosity can kill the cat, and there might be an attraction piece to these type of scenarios. So let's put the probes on and launch this thing. So everything's cable tied off. We're at 10 centimeters. I know to put that stake at the soil surface at that yellow tape mark. We come up the pole and there's just excess wire. I've cabled and quartered it off. So we've got everything cable tied off. I'm going to put this rebar at the soil surface at that yellow tape. We come up, the cable goes to a little coiled area where it's kind of out of the way and bundled up, and then right here at about 76 centimeters is the Datalogger, and then the ambient air temp. You can see that kind of hanging out in the air. So we really want to see what the difference is between the air temperature changes and the soil temp. So we're going to put this sucker up right in front of the little climbing thing at the play structure, and leave it for about 6 to 8 hours and come back to it. It's just around 8 o'clock, so it's just starting to launch and we're in good time. So let's come back.